So today we're going to finish up this unit talking about systems of inequalities, so when it has an inequality sign. So just a refresher, how to graph a system of inequalities, same way to graph an inequality. So we're going to turn on the Inequalities app. So apps and then number 2. Okay, and then we're going to type in the inequality with a correct symbol, and then we're going to this is what's different. We're going to use this to find our intersection area. All right, so we are going to have to decide when given a graph if these points are solutions. So the way to do that when given a graph is to check where these points are and see if they're in the overlapping area. So -1, 0 is right here. That is in the intersection area, so yes, it's a solution. 2, 3 is not in the intersection area. 0, -4 is not in the intersection area. -1, 3 is in this area, but it's on a dotted line, so it's not an answer. If it was on the solid line, then yes, it would be an answer. -2, 5. Yes. So that is in the shaded area, but it is not touching this dotted line, so yes, it is a solution. So now, if we're given a system of inequalities, we have two ways we could do this. We could solve for y and use this method, or we can do it algebraically, and I'll show you both. So in order to graph this, we need it set equal for y. So for this first one, I'm going to subtract 3x from both sides and get y is greater than or equal to -3x minus 3. Okay? For this one, I have x plus 2y less than or equal to 4. So again, I'm going to subtract x from both sides. Divide everything by 2. And I get y is less than or equal to -1/2 x plus 2. Okay? So now I can graph those in my calculator. So greater than or equal to, I want this symbol, so alpha y equals, to change, and then put in the expression. Okay, this one, I want less than or equal to, so I'm going to press alpha and the button underneath that, and then it's -1/2 x. Now remember, with fractions and inequalities, you need to use parentheses. And the x goes outside the parentheses. Alright, so now I'm ready to graph. There's my first inequality. There's my second inequality. And this waffle area is what we're looking at. That's where they're both overlapping. So you can leave it like this, or you can find the intersection by using alpha y equals 1. So 1 stands for the intersection, because that's where they're overlapping each other. So it will erase everything except for the lines and the intersection area. Alright, so this is our solution area right here. So now they're asking, how do I determine if this point is a solution? So my point is 2, 1. So if I'm graphing, I'm going to find 2, 1 on my answer, on my graph. So 2, 1. Yep, it's on a solid line, which means it's included, and it's near the shaded area. So yes, it is a solution. Now, if we want to do it algebraically, we're going to plug in the x and the y value into the first inequality and decide if it's true. So I'll have 3 times 2 plus 1 greater than or equal to -3, and we need to decide if that's true. So 3 times 2 is 6. 6 plus 1 is 7. And 7 is greater than or equal to -3. Now if this was not true, then I wouldn't need to test the second one, because it has to be a solution to both. So now, because it is a solution to the first one, we need to check if it's a solution to the second one. So again, I'll plug in my x and y values. And then I'm going to do the math and see if it makes sense. So we have 2 plus 2. That makes 4. So 4 is less than or equal to 4. So 4 is equal to 4. If this line wasn't there, then that would be not true. But it is. It's saying 4 could be equal to 4, which it is. So both of them worked, which means it is a solution.